Hello, in this video, we will talk about descriptive statistic and we'll focus on measures of variability, spread of the data. So this is the summary of the measurements of descriptive statistic, and today we will focus on variation, variability, the spread of the data, and we'll talk about the range, the variance, the standard deviation, also the MAD, and the coefficient of variation. So let's start. Here are three distributions that represent three classes. Let's call them the red class, the blue class, and the green class. What we observe in this graph is that all three classes have a central location, an average in this case of 70, in a specific exam that these three classes have been taken. The question is, are all three classes the same? Are the data the same? And the answer is no. We can see that the green class, the observations are more spread around the mean, around the center, compared to the red or the blue class. We can see that the red class, most of their observations are closer to the average 70 mark. When we look at the green class, we can see that we have more students that falls on the extreme, far away from 70, either up a high mark or low, a lower marks. So these three classes are totally different classes. They got the same average, but they're not the same. So what we're looking to see in this video is how can we describe, how can we use numerical values to tell us the story about the changes, the differences between these three classes. And we call them the measurements of variability. So we'll talk about the range, MAD, variance, and standard deviation. And let's start with the range. So the range is the difference between the largest and the smallest observation that you have in a data set. Now, the problem with the range is that we don't know how all the observations spread out between these two upper and lower bound. Are they skewed to the right? Are they a bell shape? Or are they skewed to the left? The range cannot assist us in answering these questions about the distribution. So it just gives us a distance, but not more than that. Another way for us to find out how data are spread is using the deviations. So in this example, we have 8 observations labeled by x1, x2, up to x8. You can see the blue boxes representing those observations. Let's assume that this line here in the center represents the center location, the average of all 8 observations. In order to understand how these 8 observations are spread around the center, what we will need to investigate are the distance from each observation to the center. So for example, if I'll take x1, the distance from that point to the center is by calculating the difference between x1 and x bar. In this scenario, if x1 is a smaller value than x bar, we will result with a negative difference. Alternatively, I can also calculate the difference, for example, to reflect how far x6 is from the center. So again, what I will do is I will calculate the difference between x6 and x bar. In this scenario, since x6 is a higher number than x bar, the result of the calculation will be a positive number. And we can do that for each observation in our series of 8 observations. Here is an example of a few of them. But clearly what you can see is that all the deviations that you're calculating on the left-hand side will result with a negative result. All the deviations on the right-hand side will result with a positive result. The problem is that if we'll average them or we'll add them, the result will cancel each other because of the opposite signs. So we need a different mechanism to help us assess the whole spread of the data around the center. So we are going to use deviation, but what we would like to do is to cancel the cancellation effect of the signs. So how do we do that? There are two ways of taking a difference, whatever it's a positive or a negative number, and canceling the sign of the result. One option is to take the absolute value of the difference, and another option is to square the difference. By doing that, the result will reflect the distance and will take out the component of the sign resulted from the position of each observation. So both MAD, mean absolute deviation, and the variance rely on this technique to calculate the spread of the data. Let's start with the mean absolute deviation, what we call MAD. This is less useful measurement for the spread of the data, but in some application like forecasting, you can see that it's been used quite often. So let's see how actually this has been calculated. Basically what we do is we sum the overall absolute deviations and we divide by the numbers of observations to get the average dispersion. So here's the calculation, the sum of the absolute deviation divided by the numbers of observations. Here's an example. Let's say you have a set of data, in this case, 7 observations. If we'll calculate the average, we'll get that it's equal to 5. If you calculate the difference between each observation to the average, you can see that some values are positive and some are negative. To cancel this cancellation effect between negative and positive numbers, we have absolute each deviation and we total them to 18. If you take that 18 and divide by 7 observations, you will get the mean absolute deviation, 2.57. As a standalone value, 2.57 doesn't mean anything, but if you will compare it to different sets of data, the data set that will have the higher MAD means it has the higher spread. The next observation is the variance, and it's related to be one of the most important statistics used to measure variability. And also we'll see that it's play a very vital role in many statistical inference procedures. So let's start first of all by separating the calculation to two groups. It depends the origin of your data. Are you dealing with population data? So you'll use sigma square equation, or are you using a sample data? So you'll use S square equation. Both equation on the numerator will calculate the sum of the squared deviation. The denominator will be different. For population, we'll divide by the population size. For the sample, we will calculate it divided by the sample size minus 1. There is another formula for sample variance, which is called the shortcut formula. That is very useful, which is applied here in the slide. Let's see an example. Here is the set of data of 7 observations. I have calculated the deviation, but then I square them. I total all the square deviation to 62. If we are assuming this is a sample variance calculation, so the data set is a sample, we will divide 62 by n minus 1, which is 7 minus 1. Result with 10.33. So this is the variance of our sample set of data. The standard deviation is simply the square root of the variance. So if you got the value, for example, 9 for variance, so your standard deviation will be 3. The standard deviation is a very useful measurement. It will help us to compare variability of several distributions. And again, the distribution with the highest standard deviation known to be more spread. And also will help us to make statement about general shape of the distribution. So let's see some applications. The first one is called the empirical rule. And it says that if the histogram is a bell-shaped histogram, which is symmetric, we can use the empirical rule and to say that approximately 68% of all observations fall within one standard deviation of the mean. So if you look at the graph on the left, the histogram, the center is 0. If you take one standard deviation to the right or one standard deviation to the left, you will cover about 68% of your observations. Similar concept, you will cover 95% of all your observations if you move 2 standard deviation to the right or 2 standard deviation to the left. And about 99.7% if you move 3 standard deviation to the right or 3 standard deviation to the left. So this is a very useful rule that will allow you to calculate later on different probability assessments or values that are falling under a certain probabilities. Another measurement that related to application of standard deviation and central location is the coefficient of variation. When data comes from very different populations and different means, it's often useful to express the standard deviation relative to the mean. So what we do is we calculate the ratio of the standard deviation. Here for the sample is labeled by S over X bar. And we represent it as percentage, so that's why you see it's multiplied by 100%, and we label it as CV. Now, it's a very useful measurement in finance to relate risk to return, because when the coefficient of the variation of 2 or more distributions are compared, the distribution with the largest coefficient of variation is said to have greatest relative spread. So this completes the video that represents the measurements of variation.